It's Algebra 2, spring test week number 9. We got through 13.2. We're talking about radian measures. Number 1 says to write an expression as a single logarithm. The directions could also say condense this logarithm. Remember, when you have the same base, like log base 7 of these, and I know it seems like it's been a long time since we did this, so I put this on here where you guys would remember it. Same base, log 7. You combine subtraction. Remember, it pairs with division. So this is going to turn out to be log base 7 of 10 divided by 5. So we can go one more step past that because we know what 10 divided by 5 is. It's log base 7 still of 2. There it is written as a single logarithm. Number 2 tells you to do the opposite, expand it. The first one was to condense it. This one's to expand it. Um, the first thing we're going to do is it says log base 8, and then it says 6 times c to the 4th. The first thing we're going to separate, since we're undoing it, remember, normally you work, please excuse my dear Aunt Sally as your order of operations. When you undo it, you go backwards. So before we do exponents, so again, you work your order of operations backwards. So before you do c to the 4th, before you do that, you undo 6 times c. Just like a second ago, subtraction was paired with division, right here, multiplication is paired with addition. So you're going to write it as log base 8 of 6 plus, because again, this multiplication right here pairs with addition, plus log base 8 of c to the 4th. But there's one more thing to do, since that's that 4th up there, that exponent. Remember, you want to move that exponent into the coefficient position. You want to move that up front right here. So what it turns out being log base 8 of 6, just like that, plus 4 times log base 8 of c. There it is written as an expanded logarithm. And again, that's just the opposite of what we did for number 1. We condensed it or put it together. For number 2, we made it longer. Number 3 tells you to use the change of base formula to solve 10 to the 4x is equal to 47. Remember, it says to use the change of base formula, and you're going to have to. But if you can change the bases to be the same, it's much easier. In this case, 10 and 47 don't share any roots, so we can't change both of them. So what you want to do is you want to take the logarithm of one of the sides. And again, I'm going through this because I know it's been a while, or it seems like it's been a while since we did this. You want to take the log of whatever side the variable's on. So in this case, we're going to have the log base 10. I know you don't have to write that 10, but I'm doing it just to keep it consistent, of 10 to the 4x. And you don't have to write it because log base 10, common logs are log base 10, is equal to, remember, if you take log base 10 of one side, you got to take the log base 10 of the other side, log base 10 of 47. This, anytime you have the same base as this, they can cancel each other out. So what you're left with is 4 times x is equal to log base 10 of 47. So right here, we don't have x. We have something multiplying by x. 4 is multiplying by it. So undo that by dividing by 4. When you divide by 4, remember that's the exact same thing as multiplying by 1/4. So it might be helpful at this step, instead of dividing by 4, to multiply by 1/4, and only because of the way we're going to have to punch it in a second. So what that gives you is log base 10 of 47 multiplied to the 1/4, or to multiplied by 1/4. 1/4. So now x is equal to that. So all of that together is going to do it. Since it is a common log like 10, you actually don't have to use the change of base like it tells you. But if it were any number besides 10, you would. So we're going to do it as if it were a different number, because it's not going to change what we're going to get. X is equal to, you're going to punch it in just like this, log of 47 divided by log of 10. So all of that times 1 over 4. And you punch it in just like that. When you do, open up a parentheses before you do log 47 and close that one, and then divide it by log of 10. And again, we know that that's the common one. Close that parentheses and times it by 1 over 4, or 1 divided by 4. When you do that, you get x's value, which is x equals 0.418024, and it keeps on going. The directions tell us to round it to the nearest 10,000th. So we got to count our places to make sure we get the right one. So right here, this is your tenths, hundredths, thousandths, 10,000ths. We don't want to go any further than that. 2, the number right next to that, tells us that we'll leave that 0 just like it is. We don't change it. We don't make it go up. So x is going to be approximately then, since we're estimating, 0.418, and it would be 0 after that, but that's just a placeholder 0. There it is, rounded to the nearest 10,000. Number 4 tells you to write the expression as a single natural log. So this is exactly the same as what we did over here for number 1, except this was a common log. Number 4 just shows you it's the same as a natural log. So since we're writing it as a natural log, you work the order of operations the way they go. You work exponents first. Remember, these coefficients become exponents. So what it becomes is the natural log of 7 to the third plus the natural log of c to the third. Then, again, both of these have the same base. Natural log, and it would be of e, because that's the same thing, natural log of e, um, of 7 to the third plus the natural log of c to the third. So they're going to keep that natural log, and it's going to be 7 to the third times c to the third. 7 to the third times c to the third. This is written as a single natural logarithm. Number 5 tells you to write it in logarithmic form. Remember, 2 to the ninth is equal to 512. Log, and I had a couple people say this out loud a bunch of times, log base 2 of 512 is equal to 9. That is it in logarithmic form. Again, that's going way back to the first day of logs. Number 6, evaluate this logarithm. So it's saying log base 2 of 64. So what it's saying is 2 to the what power is equal to 64. If you have your little cheat sheet that I gave y'all, you can do it a little faster, or you could just see how many times you got to multiply 2 times itself, but it's 6. So 6 is the correct value. Number 7 says simplify the difference. Remember, you can only add and subtract things that have the exact same variable raised to the exact same exponent. So you have 8w squared minus 4w squared. You take 8 and you subtract 4 from it, and you get 4w squared. The next one, the next degree, is w to the first power. Negative 8w minus 3w. So 8 minus, negative 8, excuse me, minus 3. Both of those have negatives, so you add 8, 9, 10, 11. You get negative 11w still to the first power. And the last degree is the one, the common term that doesn't have any variable, negative 7 minus a negative. Remember, anytime you have minus a negative, it means plus a positive. So negative 7 plus 4, which is negative 3, since they're opposite terms. Cannot put those together because they are not like terms. That's all we can do. For this one, it says simplify the product. You need to distribute the 6 and the x to the 5th power. So 6 times 2 we know is 12. 6 times positive 4 we know is positive 24. You do the same with the variables. You have x to the 5th times x to the 5th. Remember, anytime you multiply the same bases like x and x, you add the exponents, x to the 5 plus 5. Do the same thing with the other one, but notice for that one of them is x and the other one is y. So it's simply going to be x to the 5th, y to the 6th. We cannot add 5 plus 6 because they're not the same base. So this will clean up and look like this. 12x to the 10th plus 24 x to the 5th, y to the 6th. Number 9, anything raised to the 0 power is 1. Number 10, anything raised to a negative exponent needs to ride the elevator. So remember, if it's not a fraction, make it 1. Since it's got to ride the elevator, it goes down to the bottom. It's still negative 5th. That doesn't change, negative 5, I mean. But now it's raised to the positive second power. So what that is 1 over negative 5 times itself, negative 5. We know a negative times a negative is a positive. 1 over 25 is your simplified version. Notice both of these bases are 5.41. Simple. So since it's multiplying, you add the exponents. You have 5.41 to the negative 4 plus 4. We know negative 4 plus 4 is 0, so we have 5.41 to the 0 power. And again, just like this one, anything to the 0 power is 1. C to the negative third times 2c to the 5th. So we have C and C. Both of those bases are the same. This coefficient that's not shown is 1. You don't need it. But 1 times 2 is simply going to give you the number 2. C to the negative third times C to the 5th means C to the negative third plus 5. Only that gets raised to those exponents, not 1 and not 2. So you add those two together and you get 2C to the second power. That's the only thing you can do with that. 13 says 7g to the ninth to the third. 7 gets raised to the third. So 7 to the third. And g to the ninth gets raised to the third. Now, when you multiply the same bases, you add the exponents. But in this case, when you raise a power to a power, you multiply the exponents. So we're going to have g to the 9 times 7, which is going to give us g to the 6 to the third power. 7 to the third power, we can do that, and we can even cheat on our little chart if we have it. 7 to the third is 343, or simply 7 times itself 3 times. X to the third divided by x to the 8th. Remember, division pairs with subtraction. If you divide the same bases, you subtract the exponents, and you'll have x to the 3 minus 8, which is going to give you x to the negative 5th. Again, some of you can look at that and see, okay, well, 8 is a bigger number than 3, and I know I got to subtract them, so I'll just put 5 at the bottom. Yes, you can. But if you don't, you'll wind up with something like this, x to the negative 5th, and just like a minute ago on this one right here, since it's a negative exponent, it's got to ride the elevator. It's got to go down to become 1 over x now becomes to the 5th power, positive, 1 over x to the 5th. So number 15, same thing I just told you about 14. Since we got to subtract the exponents, they're both 10, we subtract 8 minus 10. We're going to get the number 2, in this case negative 2. It's going to have to ride that elevator. If you can recognize right away that 10 is the bigger number, you can just put it as 1 over 10 to the positive 2, because that's what it's going to wind up being on the next step anyways. 1 over 10 squared is simply 1 over 100. The difference being between number 14 and 15 is x was a variable, so we couldn't evaluate that out. 10 is a number. We can do 10 times 10. G to the negative 5th, h to the negative 10th, divided by g to the negative 14th, h to the negative 5th. So right here, I'm going to write this step out. It's not necessary for you to do this. Same basis. G to the negative 5th divided by means minus a negative 14. Remember, minus a negative tells you to add those numbers. So G to the negative 5th plus 14 gives you G to the ninth. With your h's, you have h. I'm going to have to write it down on this next one because I can't fit it. H to the negative 10th minus a negative 5. Again, minus a negative means plus a positive. Negative 10 plus 5 leaves us with g to the ninth, h to the negative 5th. Remember, you cannot leave a negative exponent Now I can't write and talk at the same time. G to the ninth, h to the negative fifth. You can't leave a negative exponent like negative 5. It's got to ride the elevator. G to the ninth can stay right where it is. So G to the ninth stays on top. H to the negative fifth goes down and becomes H to the positive fifth. 17 says solve this equation. It's not equal to 0. It needs to equal 0. 81 needs to go over from this side to this side. So in order to do that, you need to subtract it and make it equal to 0. If you do it there, do it here. 81 minus 9. If you borrow 1 from it, 11 minus 9 is going to be 2, and you have 7 left over. But it'll be negative since you subtracted 81. The rest of the equation is going to stay the same. X squared will be like that, and positive 6x will stay just like that. But now it's equal to 0. The difference being is now we can factor it out, or maybe we can factor it out. Let's check and see. If we open up two sets of parentheses to go from our trinomial to a binomial, we know we got to do x times x to get x squared. Our factors of c of 72 are 1 and 72. It's even, so we know 2 is going to go into it. 2 goes into 7 3 times, and there's 1 left over. So 2 goes into 12 4 times. So 2 times 34. 3 goes into it. 3 goes into 7 twice. And you know there's, again, 1 left over. 3 goes into the number 12 4 times. 4 goes into it as well. 4 goes into 7 1 time. We're getting closer. 4 goes into 7 1 time, and there's 3 left over. 4 goes into 32 8 times. 5 doesn't go into it because it doesn't end in 0 or 5. 6 goes into it. 6 goes into 7 1 time, and there's 1 left over. It goes into 12 twice. We're getting a lot closer now. 6. 7 doesn't go into it because 7 times 10 is 70. And 8 goes into it. It goes into it 8 times 9 is 72. That's all the factors, and that's a lot of pairs of factors for 72. Which one of those pairs will get us to the value B, or 6? Okay, so 1 and 72 together is either going to give us 73 or 71. This is going to give us 32 or 36. This is going to give us 21 or 27. This is going to give us 12 or 22. This is going to give us 17 or 1. Only this pair will get us to the number 6. So we got to use 6 and 12. Remember, this sign right here tells you that they're either going to be the same sign or opposite signs. Negative means they're going to be opposite signs. Since they're opposite, this one tells us the sign of the bigger number. 12 is a bigger number than 6. It's positive, so 6 is negative. So x minus 6 times x plus 12 equals 0. So we're almost done. Now we just have a very small, simple part of the equation to do. The first equation, this one, x minus 6 equals 0. Or this part, x plus 12 equals 0. Add 6 to both sides, x is 6. Or subtract 12 on both sides, x is negative 12. Now we got two answers. 6 or negative 12. A lot of work to get through that one. Again, this, I talked a lot right here. You can eliminate a lot of that work because you know you got to get to the number 6. Number 18, rewrite this one in vertex form. Remember, vertex form is like completing the square. In order to do that, you need to come up with a new c value. It's got to go to the other side. It says negative 6, so add 6 to both sides. That gives you y plus 6 is equal to x squared plus 4x, and we need to find a new c value. In order to find a new c value, remember how to find c. Remember how to find c. Take b's value divided by 2 and square it. B's value right here is 4. 4 divided by 2 is 2, and 2 squared is 4. So our positive 4 is our new c value. Remember, when you have positive 4 on one side, you got to add it to the other side. So now we have y plus 10 is equal to, we have a perfect trinomial right here. We can take the square root of the first term, x squared, and get x, and the square root of the c term, 4, and get 2. And this is the sign that goes between them, plus 2. X plus 2 squared, binomials being squared. That's not vertex form, though. In order to be vertex form, it has to have y by itself. So in order to get y by itself, we simply want to move plus 10 to the other side by subtracting 10. Remember, you can't subtract 10 inside of the parentheses. You can simply subtract it from the side. So y is equal to x plus 2 squared minus 10. That is vertex form. And remember, the vertex is shown as the opposite of what's in parentheses, so that's your x value, negative 2, and exactly what's outside the parentheses, negative 10. So at negative 2, negative 10 is going to be the bottom of that parabola. Number 19, sketch these angles. So this is the new stuff. Sketch these angles in standard position. Remember, this one says 50 degrees, positive 50 degrees. Positive tells us we know we're going to start here. This is our initial ray. We know we're going to go up since it's positive. You know, if you go all the way up, straight up, you get to 90 degrees. You know, half of 90 is 45 degrees. So we know this is 45 degrees. We have to go past that because we're going to approximately, and that's why it says sketch 50 degrees. Right past 45 degrees, that is approximately, or a sketch version of 50 degrees. Negative 340, all negative tells us, remember, just like all positive told us to do is go up, all negative tells us to do is go down. So we know we're going to go this way. We know 360 degrees is all the way around. So we're not quite going 360 degrees. We're going 20 degrees fewer than 360. So all the way around again is 360. We're not quite going that far. We're going 20 degrees fewer or less than 360. We're going like this. Make sure you draw the arc showing how far you're going. That's considered negative 340 degrees. 21 says find the angle measure between 0 and 360 coterminal with an angle of negative 113 degrees. This is the one I was telling you guys about that isn't written exactly like the examples we've been doing. On the examples we've been doing, they were actually harder because it told you to find both a positive and a negative coterminal angle. This one, you're finding one of them depending on which one you need. It has to be between 0 and 360. So you're not making more than one revolution. You're making inside of one revolution. So if we look at this one, we know negative 113 degrees. Again, it's going to start at your initial ray, and it's going to go down right past 90 degrees. So it'll be somewheres right there. That's negative 113. The one between 0 and 360 is the one that has to go the other way. This one is going to be the coterminal angle between 0 and 360. So all you have to do is take 113 and subtract it from 360. 360 minus 113. If you borrow, 10 minus 3 is 7, 5 minus 1 is 4, and 3 minus 1 is 2. That is your coterminal angle, 247 degrees. 22 says in navigation, this was kind of tough, a bearing is the angle of a course measured in a clockwise direction from due north. So think about that. That's a lot of information in that one sentence. Bearing is measured clockwise from due north. Find the positive angle in standard position from a ship's bearing of 300 degrees. So, simple. So take a look at what we've been doing. We know our initial ray is there. That right there, 0 degrees, is north. We know that that's north. So you have to kind of turn your head to know that this over here is south. This right here is west, and this right here is east. Notice that's like a compass turned on its side. Everything you know about compasses, it's kind of on its side. North, south, west, and east. It says it's positive 300 degrees. So if your ship represents your coterminal, or not your coterminal, excuse me, if your ship represents your terminal side, it's going to be at 300 degrees. So you know that it says clockwise direction. So that doesn't, that's opposite of 300 degrees, or what its bearing is, 300 degrees. So it's going to go clockwise. Find the positive angle in standard position for a ship's bearing of 300 degrees. So even though this is clockwise and typically that is negative, bearings are only positive values. So bearings are from there. So if you go 300 degrees, we know 360 is all the way around. If you go 300 degrees, we're going to go 60 less than that. So it's going to be right here, and it's going to be this direction. That is a bearing of 300 degrees, even though we know that that's a negative angle. So right there, that's the little ship. That's where it is. So picture a little ship right here. All right, that's the ship. Get my artistic ability. There it is. That's the ship. Mathematically, it's simple. It says find the positive angle in standard position. What is that as a positive angle? What is that as a positive angle? That's real simple. 60 degrees. So its positive angle is simply the coterminal angle, even though it doesn't say, and this is the tricky part, even though it doesn't say negative 300 right there. The directions tell you it's all clockwise for bearings. So mathematically, that is a 60-degree angle. In which quadrant does the terminal side, this is simple, of negative 112 lie? You don't even have to draw it, but if you do, you know it's going to be negative 112. It's going to go down, and it's going to end right here. Which quadrant is that? 3. Remember, it's 1, 2, 3, 4. This one, 3. Write the measure in radians. Express the answer in terms of pi. Okay, so right here, we're trying to put radians in. So we're multiplying it by either pi over 180 or 180 over pi. If we're trying to put it in, we're putting our pi's right there. So pi over 180. So a positive times a negative, we know it's going to be a negative. Right away, 10 cancels out 10, so we're dealing with a lot smaller numbers. 16 and 18, we know that the number 2 goes into both of them. It goes into 16 negative 8 times, so negative 8 times pi, and we know it goes into 18 9 times. Negative 8 pi over 9. This looks like it's hard, but when you do it, it's real simple because you cancel big numbers and you make small numbers, and everybody can handle small numbers. 45 degrees, same format. You're going to multiply it since you want to increase or include pi, pi over 180. Again, cancel out what you can. The number 9 goes into both of these. 9 goes into 45 5 times. So 5 pi over, it goes into 180 20 times. It goes into 18 2 times and into 180 20 times. So right here, look at the difference between number 24 and 25. This one says 5 pi over 20. You can reduce this one more. The number 5 goes into both of these. Don't leave something unreduced. 5 goes into itself once and into 20 4 times. So this is simply written as pi over 4. Pi over 4. 26 says to write these in degrees. When you want to write degrees, you want to get rid of pi. So you have 8 pi over 5. So you're multiplying it now by pi at the bottom where we can cancel it out. 180 over that. The number 5 goes into both 5 and 180. It has to because 5 and 0. It ends in 5 and 0. It goes into itself once. 5 goes into 18 3 times, and there's 30 left over, so it goes into that 6 times. So pi cancels out pi. So now all we simply have is the number 8 times 36. 8 times 6 is 48. Carry your 4. 8 times 3 is 24. Plus 4 is 28. This is 288 degrees. Negative pi over 2 radians. Negative pi over 2. Again, you want pi eliminated, so put it at the bottom. Times 180 over that. 2 goes into both of these. It goes in itself once and into this one 90 times. This cancels out this. Don't lose the negative. It is negative 90 degrees.